Time, sphere and distance is a very important chapter for your campus placements preparation. There will be at least one question from the concepts covered in this chapter, no matter which company you consider. It also happens to be one of the favorite chapters of TCS, as we see a variety of questions, rather difficult questions, being asked from this chapter in both TCS Digital as well as TCS Ninja. The chapter is lengthy and yet very interesting. It is a chapter with a steep learning curve. There are myriad question types, subtopics, and concepts to master, but yet, by the end of the chapter, everything coalesces and traces back to the basic concepts taught in the first lecture. Now, before we start with the first lecture, I assume that we are already aware of the basics of time, speed, and distance. If you still have a need to master the basics of time, speed, and distance, then we have a separate video by the name of Basics of Time, Speed, and Distance. Please check that out first. As far as the first lecture is concerned, we will be mainly covering two topics. We will understand the concept of inverse variation between time and speed, discuss some commonly seen examples, and then we'll be finishing the lecture with some discussion on average speed. So, let's start with the first topic of the day, concept of inverse variation between time and speed. We all are aware of the formula speed is equals to distance by time. Now, if speed is equals to distance by time, what happens if I keep this distance as same or constant? Can I say that if my distance becomes constant, from here the first thing that I derive is that speed becomes inversely proportional to time, or speed and time are in inverse variation? Now, what do I mean when I say speed and time are inverse variation? Let's understand that using a simple example. Let us say that there are two students, let's call them as student A and student B, and इन दोनों ने एक certain fixed distance travel करना है. Let us say इन दोनों ने 100 kilometers का distance travel करना है. So I have two students, student A and student B, and both of them have to travel a distance of 100 kilometers. In a way, what I am saying is that for comparing these two students, the distance traveled is same or constant. So ये दोनों का जो distance traveled है वो same या constant हो गया. Furthermore, it is given to me that the speed of student A is 20 kilometers per hour and the speed of student B is 25 kilometers per hour. Now, if person A has to travel 100 kilometers with a speed of 20 kilometers per hour, he would be taking a total of 5 hours. And if student B or person B has to travel the same distance with a speed of 25 kilometers per hour, he would be taking 4 hours. Now, if speed is in inverse variation to time, in a very simple sense, what it means is that जिसका speed ज़्यादा होगा उसका time कम होगा and vice versa. In this particular example, compared with A, B का speed ज़्यादा है. क्योंकि A के comparison में B का speed ज़्यादा है and both of them are traveling the same distance, then the time taken by B will be less in comparison to the time taken by A. That's the essence of speed being in inverse variation to time. Also, if speed is equals to distance by time, from here, can I say that distance is equals to speed into time? Now, if distance is equals to speed into time and I have kept my distance as constant, then from here, can I say that the product of speed and time is constant? Now what happens when two variables are in product constancy? अगर दो variables आपस में इस तरीके के रिलेशनशिप में है जहां पे उनका प्रोडक्ट कांस्टेंट रहता है, तो कैन आई से एक वेरिएबल के इंक्रीज के कॉरस्पॉन्डिंग दूसरे का डिक्रीज होना चाहिए और एक वेरिएबल के डिक्रीज के कॉरस्पॉन्डिंग दूसरे का इंक्रीज होना चाहिए. लेट मी एक्सप्लेन दैट. अगर स्पीड और टाइम प्रोडक्ट कॉन्स्टेंसी के रिलेशनशिप में है, अगर स्पीड डिक्रीज होगा तो प्रोडक्ट को कांस्टेंट रखने के लिए टाइम को इंक्रीज होना पड़ेगा एंड वाइस वर्सा अगर स्पीड इंक्रीज होगा तो प्रोडक्ट को कांस्टेंट रखने के लिए टाइम को डिक्रीज होना पड़ेगा. मैथमेटिकली इफ स्पीड इंक्रीजेस बाय r%, अगर स्पीड r% से इंक्रीज करता है तो उसे कंपनसेट करने के लिए टाइम डिक्रीजेस बाय r अपॉन 100 प्लस r. ऑब्वियसली अगर हम इसे परसेंटेज में लेके जाना चाहते हैं तो वी मल्टीप्लाई दिस विद 100. So an increase of r% in one variable results in a decrease of r upon 100 plus r into 100% in the other variable. Other way around, अगर स्पीड r% से डिक्रीज करता है तो टाइम इंक्रीज होगा. दैट इंक्रीज विल बी गिवन एज r अपॉन 100 minus r. So r upon 100 minus r into 100 will be the increase in other variable. Hopefully we are able to understand this relation. We have already discussed this relation in detail in the chapter of percentages. Next, if speed and time are in product constancy, that's like saying that if I take the speed of first person and multiply that with the time of first person, what I get is the distance traveled by first person. Also, if I take the speed of second person and I multiply that with the time taken by second person, what I again get is the distance traveled. Now, since these two distances are equal or constant, from here can I say that the product of speed and time for the first person equals to product of speed and time for the second person? Let me elaborate what I am saying using this example. Speed of first person is 20. So speed of first person into the time of first person gets me the distance traveled by first person, which is 100 kilometers. Also, the speed of second person into the time traveled by second person again gives me the distance traveled by the second person. Now, since the distance traveled in both cases is same or constant, from here I can say that the speed of first person into the time traveled by first person is equals to speed of second person into the time traveled by second person. This is the third postulate which follows from distance being constant. अगर दो लोगों के लिए distance traveled same या constant हो गया है, from here I can say s1 t1 is equals to s2 t2 is equals to distance d, and this is constant. Hopefully, we are able to follow how this equation derives from distance being constant. Fourth and final postulate that follows from here is actually derived from this equation itself. If S1 into T1 is equals to S2 into T2, from this equation, can I say S1 by S2 is equals to T2 by T1? Now, what do I mean when I say S1 by S2 is equals to T2 by T1? Well, what was S1? S1 was the speed of first person. What is S2? S2 is the speed of second person. So, S1 by S2 is the ratio of speed of first person to the speed of second person. Now, what is T1? T1 is the time taken by first person. What is T2? T2 is the time taken by the second person. So what is T1 by T2? It is the ratio of the speed, it is the ratio of the time taken by first person to the time taken by second person. Now what we observe in this relationship is that whatever is the ratio of speeds, the reciprocal of that is the ratio of times. तो अगर person 1 and person 2 की ratio of speeds let's say मेरे पास A is to B दी हुई है तो उनका time taken B is to A होगा. Hopefully we are able to follow this. So whatever is the ratio of speeds, the reciprocal of that or the inverse of that ratio is the ratio of times and vice versa. So next time you encounter a question जहाँ पे speeds का ratio मेरे पास let's say A is to B दिया हुआ है, उसको देखकर मैं directly कह सकता हूँ कि भाई times का ratio B is to A होगा. अगर मेरे को times का ratio X is to Y दिया हुआ है, वहां से I can directly say that the ratio of speeds is Y is to X. Hopefully we are able to follow these 4 points. As far as the concept of inverse variation between time and speed are concerned, these are the 4 main points that follow. इसके ऊपर जितने भी एग्जांपल्स होंगे वो कहीं ना कहीं घूम फिर के यही 4 पॉइंट्स में से किसी एक के ऊपर वर्क करेंगे. Let's try out some examples now. if I travel at 3/5 of my usual speed, I take 14 minutes more than the usual time taken to reach my office. How much time I take usually? इस क्वेश्चन में जो पहली चीज मुझे गिवन है वो ये है कि डिस्टेंस ट्रेवल सेम या कांस्टेंट है. In the previous discussion we have learned that when distance traveled becomes same or constant, these 4 points follow. What I'll be doing here is that I'll be using this example to help you understand 3 different methods of solving this question, and then over the next examples we'll learn कि कौन सा method कहाँ पर लगाना चाहिए. The first method that we have here is what I like to call as the ratio method. Ratio method uses the fourth point that we developed. Ratio of these speeds is reciprocal of the ratio of times. हमने पिछले डिस्कशन में समझा था कि जब डिस्टेंस को कांस्टेंट किया जाता है तो जो स्पीड्स का रेशियो होता है उसका रेसिप्रोकल टाइम्स का रेशियो होता है. नाउ विल बी सॉल्विंग दिस एग्जांपल यूजिंग दिस रेशियो मेथड. The first thing given to me in this example is that I travel at 3/5 of my usual speed. That means if I'm supposing my usual speed as x, my new speed has to be 3/5 of x. Now that's a fancy way of saying that the ratio of my usual speed to my new speed is going to be 1:3/5. On simplification, this ratio turns out to be 5:3. If the ratio of speeds is 5:3, then the ratio of times has to be the reciprocal of that. It has to be 3:5. So when I say that the ratio of speeds is 5:3, from here I can say that the ratio of the time taken is 3:5. Now, if the ratio of time taken is 3:5, then from here can I say that if I have to suppose, then I must be supposing my usual time as 3x and my new time as 5x. As per my given question, I took 15 minutes more than my usual time. तो ये मेरा usual time था, ये मेरा new time है. New time में usual time से 14 मिनट ज़्यादा लगे हैं. That's a fancy way of saying कि इनका जो difference है 2x, that has been given to me as 14 minutes. From here I deduce the value of x as 7. Now if x is 7, my initial time or my usual time, which was 3x, ends up becoming 21 minutes. Hopefully we are able to follow this example. Now frankly मैंने इस एग्जाम्पल को इतनी डिटेल में इसलिए करवाया है ताकि आप इस कंसेप्ट को फॉलो कर सकें. ऑब्वियसली अगर आप अपने एंड पे क्वेश्चन सॉल्व कर रहे हैं तो आपको ये सारे स्टेप्स लिखने की जरूरत नहीं थी. आप डायरेक्टली इस चीज को मेंटली सोच सकते थे एंड यहां से कह सकते थे दैट ओ द रेशियो ऑफ स्पीड्स इज 5:3, द रेशियो ऑफ टाइम्स इज 3:5, 3x 5x, डिफरेंस 2x, 2x equals 14, x equals 7, therefore 3x equals 21. Okay, using this method you could have solved the question orally. Hopefully we are finding the ratio method very helpful in solving such questions. This is the first method at hand. Now let's move on to the second method. In the equation method, we utilize this equation S1T1 is equals to S2T2 equals to distance d. It is given to me that I am traveling at 3/5 of my usual speed. So the first thing that I do here is that I assume my usual speed or S1 as x. Now if my original speed or usual speed is being assumed as x, can I say my new speed or S2 is 3/5 of x? Furthermore, it is told to me that I take 14 minutes longer. That means if I assume my original time as t, my new time should be t plus 14 minutes. Since I'm supposing this time in hours, I cannot directly add 14 minutes to it. I need to convert these 14 minutes into hours as well. So if I suppose my original time to be t, my new time ends up becoming the original time plus 14/60 hours. Now this is S1, this is T1, this is S2, this is T2. I can take all these four values and substitute them into the equation S1 T1 is equals to S2 T2. So S1 into T1 is equals to S2 into T2. Now when we solve the equation, the first thing that happens here is that x gets cancelled out. इसके बाद मैं 5 को इधर जाकर मल्टीप्लाई कर सकता हूँ, सो 5t इक्वल्स 3t प्लस 3 इंटू 14/60। जब 3 इंटू 14/60 करेंगे तो 360 से कैंसिल होकर 20 छोड़ देगा डिनोमिनेटर में, सो दिस इज बेसिकली 14/20 और परहैप्स 7/10। नाउ 5t इक्वल्स 3t प्लस 7/10, 3t को लेफ्ट साइड पे लाके माइनस कर लेते हैं, सो 2t इक्वल्स 7/10 or the value of initial time ends up becoming 7/20. But remember, t has been supposed in hours. So if the value of time ends up becoming 7/20 of hours, I can convert that into minutes by multiplying that with 60. So my answer again turns out to be 21 minutes. This is the second method of solving such questions. Now let's move on to the third and final method of solving such questions. In the method of product constancy, I utilize the fact that when distance becomes constant, the product of speed and time becomes constant. So I begin the question by writing this simple equation, St equals constant. If the product of speed and time is constant and it is told to me that now I am traveling at 3/5 of my usual speed, then can I say कि अगर मेरा ओरिजिनल स्पीड s है तो मेरा नया स्पीड 3/5 ऑफ s हो जाएगा। इस इक्वेशन में जहां पे स्पीड और टाइम दो वेरिएबल्स थे जो कि प्रोडक्ट में थे, अगर मैंने स्पीड को 3/5 किया है तो दैट्स लाइक सेइंग द फर्स्ट वेरिएबल हैज बीन मल्टीप्लाइड बाय 3/5। मुझे स्पीड और टाइम का प्रोडक्ट कांस्टेंट रखना है। अगर मैंने पहले वेरिएबल को 3/5 से मल्टीप्लाई किया है और मैं चाहता हूं कि इनका प्रोडक्ट कांस्टेंट रहे, तो मुझे दूसरे वेरिएबल को इसके रेसिप्रोकल 5/3 के साथ मल्टीप्लाई करना पड़ेगा। दैट मीन्स in order to keep the product constancy of speed and time, if speed becomes 3/5 of original, time must become 5/3 of original to keep the product constant. Now, if the new value of time is 5/3 of original, can I say increase in time can be defined as new time minus the original time? So 5/3 of original time was the new value of time, t was the original value of time. So इन दोनों का difference जो 2/3t है, that is the increase in value of time. Now if 2/3t is the increase in value of time, then as per my given question, this 2/3t corresponds to 14 minutes. इसको solve करके मैं original value of time को 21 minutes निकाल सकता हूँ. That's my third method, or the method of product constancy. I have used this equation to help you understand three different methods of solving such questions. जहां पे भी डिस्टेंस को मैंने कांस्टेंट रखना है तो यही तीन मेथड्स में से कोई एक मेथड फॉलो होगा क्वेश्चंस को सॉल्व करने के लिए। That does not mean that we should pick up one method जो मैं सबसे ज्यादा पसंद आया है and forget the other two. You have to know all the three methods because frankly all the three methods will find their applications in different type of questions. कुछ क्वेश्चंस ऐसे होंगे जो रेशो मेथड से ज्यादा डायरेक्ट हो जाएंगे, कुछ क्वेश्चंस ऐसे होंगे जिनके लिए मुझे इक्वेशन मेथड ही लगाना पड़ेगा, वहां पे रेशो मेथड लगेगा ही नहीं, और कुछ क्वेश्चंस ऐसे होंगे जहां पे हम डायरेक्टली प्रोडक्ट कॉन्स्टेंसी के साथ क्वेश्चन को ओरली सॉल्व कर सकते हैं. सो इट इज नेसेसरी, आई रिपीट, इट इज नेसेसरी दैट यू शुड नो ऑल द थ्री मेथड्स ऑफ सॉल्विंग दोज क्वेश्चंस जहां पे डिस्टेंस कांस्टेंट रहता है. Hopefully example 1 is clear here. Now let's move on to the second example of product constancy. Three cars A, B and C travel a distance of 945 meters each with a speed of 5 meters per second, 15 meters per second and 45 meters per second. Calculate the ratio of the times taken. In the given question, the first thing that I have is that the distance traveled by the three cars is same. तीनों ने 945 meters का distance travel करना है, so basically तीनों ने same distance travel करना है. Furthermore, it is given to me that the speeds of three cars are 5 meters per second, 15 meters per second and 45 meters per second. In a way, मुझे तीनों cars की speed के form में speeds का ratio दिया हुआ है. By taking these speeds into consideration, I can say that the ratio of speeds has been given to me as 5 is to 15 is to 45, which obviously is as good as 1 is to 3 is to 9. The logical question that we should be asking ourselves here is that if I'm given the ratio of speeds and I have to find the ratio of times, should I use the product constancy method, the equation method, or the ratio method? Obviously, the logical choice has to be the ratio method. So what I'm going to do here is that I'm going to consider the ratio of speeds as 1 is to 3 is to 9. Now, whatever is the ratio of speeds, the reciprocal of that is the ratio of times. So if the ratio of speeds is 1 is to 3 is to 9, from here I can directly say that the ratio of times will be 1 by 1 is to 1 by 3 is to 1 by 9. Now I can take this ratio into consideration, but it's a fractional ratio. Let us convert that into an integral ratio by multiplying the ratio throughout with the LCM of the denominator. 9 is the LCM of denominator, so I'm multiplying this ratio throughout by 9. So my final answer ends up becoming 9 is to 3 is to 1. Hopefully we are able to follow this example. As we have learned in the previous discussion, you need to know all the three methods. This question is best solved using the ratio method. Let's try out a next example here. Three swimmers swim 3 laps of a swimming pool in 10 minutes, 8 minutes and 6 minutes respectively. Calculate the ratio of speeds. The first thing given to me in the question is that these three swimmers are swimming 3 laps each. So in a way, अगर वो तीनों ही 3-3 laps swim कर रहे हैं, तो I can say that the distance traveled becomes same or constant. Now, if the distance traveled is constant and I'm given the times taken by three swimmers as 10 minutes, 8 minutes and 6 minutes, from here I can say that the ratio of times is 10 is to 8 is to 6. Now, if the ratio of times is 10 is to 8 is to 6 and I have to find the ratio of speeds, the ratio of speeds will be reciprocal of the ratio of times. So अगर मेरा ratio of times मेरे पास 10 is to 8 is to 6 है, from here I can say that the ratio of speeds will be 1 by 10 is to 1 by 8 is to 1 by 6. So 10, 8 and 6 का inverse या reciprocal. Now, if the ratio of speeds ends up becoming 1 by 10, 1 by 8 and 1 by 6, in the next step, what I should be doing here is that I should be converting this ratio into an integral ratio by multiplying the ratio with the LCM of denominators. तो यहाँ पे मेरे पास जो डिनोमिनेटर्स थे 10, 8 एंड 6, मैंने इनका एलसीएम कंसिडर किया, वो 120 था. उसके बाद मैंने इस पूरी फ्रैक्शनल रेशियो को 120 से मल्टीप्लाई कर दिया. Now 120 into 1 by 10 gets me 12, 120 into 1 by 8 gets me 15 and 120 into 1 by 6 gets me 20. So the ratio of speeds ends up becoming 12 is to 15 is to 20. Hopefully we are able to understand this example. Let's move on to the next example now. Steve and Jack travel the same distance with a speed of 10 km per hour and 15 km per hour respectively. If Steve takes 15 minutes more than Jack to travel this distance, then what was the time taken by Jack to travel this distance? इस क्वेश्चन में जो पहली चीज मुझे दी हुई है वो ये है कि स्टीव की स्पीड 10 km per hour है और जैक की स्पीड 15 km per hour है. That's a fancy way of saying that the ratio of speed of Steve to Jack is 2 is to 3. Now if the ratio of speed of Steve to Jack is 2 is to 3, from here I can say that the ratio of times taken will be reciprocal of this ratio or perhaps 3 is to 2. तो अगर स्पीड्स का रेशियो हमारे पास 2 is to 3 दिया हुआ है तो उसको रेसिप्रोकेट करके मैं कह सकता हूँ कि टाइम्स का रेशियो 3 is to 2 हो जाएगा. अब अगर टाइम्स का रेशियो 3 is to 2 है, from here what I can do is that I can suppose the time taken by Steve as 3t and the time taken by Jack as 2t. Furthermore, my question says that Steve takes 15 minutes more than Jack. तो Steve को Jack के कंपैरिजन में 15 minutes एक्स्ट्रा लगते हैं. So 3t minus 2t, t equals 15. If t equals 15, from here I can say that 2t equals 30 and 3t equals 45. What was my question? My question was, what was the time taken by Jack to travel this distance? Time taken by Jack was 2t, which is 30 minutes. Hopefully, we are able to understand the utility of ratio method for solving such questions. आप इस सवाल को इक्वेशन मेथड से भी सॉल्व कर सकते हैं, बट फ्रैंकली रेशियो मेथड जितना आसान कुछ भी नहीं है. लेट्स मूव ऑन टू द नेक्स्ट एग्जांपल्स, जहां पे अब हम इक्वेशन मेथड को यूज करेंगे. Two bicyclists travel the same distance at 16 kilometers per hour and 15 kilometers per hour. One of them takes 16 minutes longer than the other. Calculate the distance traveled by each. इस क्वेश्चन में मुझे दो चीजें दी हुई हैं. नंबर वन, two bicyclists travel the same distance. Now if they are traveling the same distance, the distance traveled becomes same or constant for two of them. Second thing that is given to me is that they are traveling this distance at a speed of 16 kilometers per hour and 15 kilometers per hour. As a result, one of them takes 16 minutes longer than the other. We have already understood in the initial theoretical discussion that speed is inversely proportional to time. Therefore, the one who is traveling at a slower speed is the one who is taking 16 minutes extra. So, if I suppose the time taken by the person traveling at 16 kilometers per hour as t hours, then the time taken by the other person will be t plus 16. तो ऑब्वियसली यहाँ पे मेरा जो स्पीड है वो किलोमीटर्स पर आवर में है, इसलिए मैंने टाइम को आवर्स में सपोज किया है. एज अ रिजल्ट जब मैं इसमें 16 मिनट्स ऐड करूंगा तो मुझे उसे डिवाइडेड बाय 60 की फॉर्म में लिखना पड़ेगा. So here I have S1 T1 as well as S2 T2. I can take these four values and substitute them into the equation S1 T1 is equals to S2 T2. Now S1 is 16, T1 is T, S2 is 15, T2 is T plus 16 by 60. इसको सिंप्लीफाई कर लेते हैं. So 16T equals 15T plus 15 into 16 by 60. Now 15 cancels 60 as 4, 4 cancels 16 as 4. So 16t equals 15t plus 4, which implies 16t minus 15t, t equals 4 hours. Now, if the time taken equals 4 hours, from here, can I say that if I have to find the distance, I can take the value of t and substitute either it in S1 T1 or S2 T2. Obviously, the easier thing to do here is to substitute the value of t in S1 T1. So can I say distance traveled becomes the product of speed 1 into time 1. Now what was speed 1? It was 16. What was time 1? It was 4 hours. Therefore, the total distance traveled has to be 64 kilometers. Hopefully, we are able to solve this question easily. You could have also solved this question using the ratio method, but it is more preferable to solve this question using the equation method. Remember, जब हमें क्वेश्चन के एंड में टोटल डिस्टेंस निकालना है, वहां पे गोइंग फॉर द इक्वेशन मेथड. जहां पे क्वेश्चन के एंड में आपको टोटल टाइम निकालना है, गोइंग फॉर द रेशियो मेथड. Let's have two more examples using the equation method. Rahul goes to his office at 40 kilometers per hour and gets late by 10 minutes. If he goes to his office at 50 kilometers per hour, he reaches 20 minutes early. How far is Rahul's office from his home? इस क्वेश्चन में मुझे दो स्पीड्स दिए हुए हैं. जब राहुल 40 की स्पीड पे जाता है तो वो 10 मिनट लेट हो जाता है. जब वो 50 की स्पीड पे जाता है तो वो 20 मिनट जल्दी पहुंच जाता है. If I take t as the reference time, can I say when Rahul is traveling at a speed of 40, he gets late by 10 minutes, therefore the time ends up becoming t plus 10 by 60. Obviously speed मेरा 40 किलोमीटर पर आवर है. क्योंकि ये किलोमीटर पर आवर में है तो मैंने टाइम को आवर्स में सपोज किया. अब अगर मैंने टाइम को आवर्स में सपोज किया तो जब मैं 10 मिनट्स लेट की बात कर रहा हूँ, दैट विल बी प्लस 10 by 60. ओके, सो 40 की स्पीड पे वो 10 मिनट लेट हो जाता है और 50 की स्पीड पे वो 20 मिनट जल्दी पहुंच जाता है. So the equation that I am creating is of the form S1 into T1 is equals to S2 into T2. इसको सिंप्लीफाई किया जा सकता है. सबसे पहले तो 0 से 0 कैंसिल हो जाएगा, 4 इसके अंदर मल्टीप्लाई हो जाएगा, सो 4T प्लस 40/60 इज इक्वल्स टू 5 इसके अंदर मल्टीप्लाई हो जाएगा, 5T माइनस 100/60. अब ये जो 100/60 है इसको लेफ्ट हैंड साइड पे मूव कर लेते हैं. सो व्हाट आई गेट हियर इज 140/60. 5T में से 4T को सब्ट्रैक्ट कर लेते हैं तो T का वैल्यू मेरे पास 140/60 आ जाता है. अब मुझे यहाँ पे टाइम नहीं निकालना था, मुझे यहाँ पे डिस्टेंस निकालना था. In order to calculate distance, I can either evaluate S1 T1 or S2 T2 because both of them equal to distance D. Now let us say I am calculating for S2 T2 this time. So S2 is 50, T2 is T minus 20/60. What is T? It is 140/60. So 140/60, that is T minus 20/60. Now that calls for 140 minus 20, 120/60. 120/60 gets you 2. So distance ends up becoming 50 into 2 or perhaps 100 kilometers. So the total distance traveled has to be 100 kilometers. Hopefully we are able to understand this question and solve this question using the equation method. One more example and then we move on to the other type of examples. Over a certain distance, if I travel at a speed which is 5 kilometers per hour more than the usual, I take 10 minutes less than usual. If I travel at a speed which is 5 kilometers per hour less than the usual speed, I take 15 minutes more than usual. Find the distance. इस क्वेश्चन में मुझे दो सिनेरियोज दिए हुए हैं. पहले सिनेरियो में मेरा जो स्पीड है वो मेरी रेगुलर स्पीड से यूजुअल स्पीड से 5 किलोमीटर पर आवर ज्यादा है एंड एज अ रिजल्ट मैं एक सर्टेन डिस्टेंस 10 मिनट्स कम में कवर कर लेता हूं. दूसरे सिनेरियो में मेरा जो स्पीड है वो रेगुलर स्पीड से या यूजुअल स्पीड से 5 किलोमीटर पर आवर कम है एंड एज अ रिजल्ट मैं 15 मिनट लेट हो जाता हूं या मुझे 15 मिनट एक्स्ट्रा लगते हैं सेम डिस्टेंस ट्रेवल करने के लिए. दोनों ही सिनेरियोज में मुझे यूजुअल स्पीड या ओरिजिनल स्पीड नहीं गिवन है. सो आई बिगिन दिस क्वेश्चन बाय सपोजिंग द यूजुअल स्पीड और द रेगुलर स्पीड एज s. So I'm supposing the original speed as s and the original time as t. Obviously speed into time always gets me distance. तो अगर मैं ओरिजिनल स्पीड के साथ ओरिजिनल टाइम के लिए ट्रेवल करूंगा तो वहां से मेरे पास डिस्टेंस आ जाएगा. नाउ एज पर माय क्वेश्चन, जब मैंने अपनी स्पीड को 5 किलोमीटर पर आवर इंक्रीज किया तो टाइम टेकन 10 मिनट से डिक्रीज कर गया. जब मेरा स्पीड 5 किलोमीटर पर आवर से इंक्रीज होता है तो टाइम 10 मिनट्स डिक्रीज करता है. दैट मींस जो मेरा ओरिजिनल टाइम था उसमें से मैं 10/60 आवर्स माइनस कर दूंगा. नाउ दिस स्पीड इनटू टाइम गॉट मी डिस्टेंस, देयरफॉर दिस स्पीड इनटू दिस टाइम शुड आल्सो गेट मी द सेम डिस्टेंस. फाइनली माय क्वेश्चन सेज कि जब हमने स्पीड को 5 किलोमीटर पर आवर से कम किया तो जो टाइम टेकन था वो 15 मिनट्स बढ़ गया. तो कहना है अगर टी मेरा ओरिजिनल टाइम है तो इसके अंदर मुझे 15 मिनट्स के कॉरस्पॉन्डिंग 15/60 ऑफ एन आवर ऐड करना है. अगेन स्पीड इनटू टाइम गेट्स मी द टोटल डिस्टेंस ट्रेवल्ड. दिस इज वन इक्वेशन दैट वी हैव, this is second equation that we have, and this is third equation that we have, and all three equations actually have the same format. Speed into time gets me distance, speed into time gets me distance, speed into time gets me distance. अब मेरे पास तीन इक्वेशंस और तीन वेरिएबल्स हैं. इनको सॉल्व करके स्पीड, टाइम और डिस्टेंस तीनों चीजें निकाली जा सकती हैं. टू स्टार्ट विद आई टेक माय फर्स्ट इक्वेशन एंड माय सेकंड इक्वेशन इनटू कंसीडरेशन. जो फर्स्ट इक्वेशन है ये भी डिस्टेंस देती है और जो सेकंड इक्वेशन है ये भी डिस्टेंस देती है. कैन आई कंपेयर दीज टू एंड से एस टी इक्वल्स एस प्लस 5 इंटू टी माइनस 10/60. होपफुली वी आर अंडरस्टैंडिंग व्हाट आई एम डूइंग हियर. ये स्पीड और टाइम का प्रोडक्ट डिस्टेंस देता था, ये स्पीड और टाइम का प्रोडक्ट डिस्टेंस देता था. क्योंकि ये डिस्टेंस सेम थे तो मैंने स्पीड और टाइम के प्रोडक्ट्स को आपस में इक्वेट कर दिया. लेट अस फर्दर सिंप्लीफाई दिस इक्वेशन. So ST equals ST minus 10/60 into S. Now 10/60 is as good as 1/6. So minus S/6. 5 into T. And finally 5 into minus 10 which is minus 50/60 or minus 5/6. फर्स्ट ऑफ ऑल दिस एस टी कैंसल्स एस टी, देन माइनस वाले टर्म्स को लेफ्ट साइड पे ले आते हैं. सो कैन आई से एस बाय सिक्स प्लस 5/6 इक्वल्स 5t. नाउ डिनोमिनेटर में जो 6 है उसको कॉमन लेके दूसरी साइड पे मल्टीप्लाई किया जा सकता है. सो फ्रॉम हियर व्हाट आई से इज दैट s plus 5 is equals to 30t. Now we have got an equation in s and t. Now I need to look out for another equation in s and t. From where can I get that? Well, अगर मैंने last time first and second को compare किया था तो now I can compare first and third. What happens when I compare the first equation and third equation? Can I say st which was equals to distance now becomes equals to this speed and time का product. So st equals s minus 5 into t plus 15/60. इसको सिंप्लीफाई कर लेते हैं. st equals s into t plus 15/60 into s. Now 15/60 is 1/4, so plus s by 4, minus 5 into t minus 5t, and minus 4 minus 5 into 1/4, which is minus 5/4. Now again st cancels st. Let's take these terms with denominator 4 onto the left side. So 5/4 minus s by 4 is equals to minus 5t. अगेन इसमें से 4 को जो डिनोमिनेटर है उसको कॉमन लेकर दूसरी साइड पे मल्टीप्लाई किया जा सकता है. सो 5 minus s is equals to minus 20t. That's another equation in s and t that I have. ये एस एन टी के अंदर एक इक्वेशन थी, ये एस एन टी के अंदर दूसरी इक्वेशन है, और इनको सॉल्व करने के लिए आपको नजर आ रहा है डायरेक्टली ऐड करना है. बिकॉज इसका लेफ्ट हैंड साइड s प्लस 5 है, उसका लेफ्ट हैंड साइड 5 माइनस s है. When I will add these two, variable s will be eliminated. So taking this equation into consideration and this equation into consideration, what happens when I add these two? S plus 5 equals 30t. 5 minus s equals minus 20t. What happens when I add these two? So plus s से minus s cancel हो जाएगा. Plus 5 and plus 5 gets me plus 10. And 30t minus 20t gets me 10t, from which I get the value of time as 1 hour. So t का वैल्यू मेरे पास 1 hour आ गया. अब अगर t का वैल्यू मेरे पास 1 hour आ रहा है तो I can take this value of t and substitute either into this equation or into this equation. Let us say I'm taking the value of t as 1 and substituting into this equation. So s plus 5 equals 30 into 1. t का वैल्यू मैंने 1 डाल दिया. From here what I get is the speed, what I get here is the value of speed s as 25. So speed हमारे पास 25 kilometers per hour है. Finally, my question wanted me to calculate the distance. As we know, speed into time gets me distance. Now, what was my original speed? 25. What was my original time? 1 hour. So, can I say distance is nothing but 25 into 1, or perhaps 25 kilometers? Hopefully, we are able to understand what's happening here. This is one peculiar question in which the only method of solving the question is to create equations. No matter what you do, no matter you try applying the ratio method, no matter you try applying the product constancy method, it won't yield you any result. The only method for solving such questions is to apply the equation method. मैंने यहाँ पे time, speed and distance के equations को create करके question को solve किया है. Hopefully we are able to understand this example. Let's move on to next example now. Due to a sudden technical problem, a train reduces its speed by 25% and hence reaches Delhi 2 hours late. If the train had left Amritsar at 7 am, then what was the scheduled time to reach Delhi? This is one particular question which is best solved using the concept of product constancy. हमने चैप्टर के स्टार्टिंग में समझा था कि जब स्पीड और टाइम का प्रोडक्ट कांस्टेंट हो जाता है तो अगर स्पीड r% से इंक्रीज करती है तो दूसरा वेरिएबल r/100 प्लस r इंटू 100 के फैक्टर से कम होता है, और अगर एक वेरिएबल r% से डिक्रीज करता है देन द अदर वेरिएबल इंक्रीजेस बाय अ फैक्टर ऑफ r/100 माइनस r. Now, in this particular question, it has been given to me that the train has reduced its speed by 25%. If the train has reduced its speed by 25%, there would be an increase in time taken. The increase in time taken will be given by the formula r upon 100 minus r into 100. So can I say the increase in time taken will be 25 upon 100 minus 25 into 100. Now 25 by 75 gets me 1 by 3, so 1 by 3 into 100 gets me 33.33%, or by a factor of 1 by 3. So what we have deduced here is that if speed reduces by a factor of 25%, the time taken increases by a factor of 33.33%. In the concept of percentage change, we have learned that whenever we talk about percentage increase or percentage decrease, that is always with respect to some original value. Now, this 33.33% ka increase in time would also be with respect to the original value of time. So what I do next is that I suppose the original value of time as x. Now, if the original value of time is x and there's a 33.33% increase in it, can I say that the increase in time will be given as 33.33% of x, and this 33.33% of x leads to an increase of 2 hours. So ये जो 33.33% of x का increase था time में, this was equivalent to an increase of 2 hours. Now 33.33% is nothing but 1 by 3. So 1 by 3 of x equals 2 hours. Therefore x, which is my original time, ends up becoming 6 hours. Now, if the original time that we have ends up becoming 6 hours, and my question says that the train had left Amritsar at 7 a.m., what was the scheduled time to reach Delhi? Scheduled time to reach Delhi was 7 plus 6, 13, or perhaps 1 p.m. So the scheduled time to reach Delhi was 1 p.m. Hopefully we are able to solve this question. Now there's an easier method of utilizing the concept of product constancy. As we know, यहाँ पे speed और time का product जो है वो constant है. अब अगर हमने speed को 25% से reduce किया है, that is like saying the speed has become 3/4 of original. If speed has become 3/4 of original, time should become 4/3 of original to keep the product constant. Now, if I say that time has become 4/3 of original, that is as good as saying that increase in time is 1/3. Now, if there's an increase of 1/3 in time, then this increase of 1/3 in time leads to the train getting late by 2 hours. From this, I can directly say that the original time was 6 hours, and therefore my answer has to be 1 p.m. Hopefully, we are able to understand how to utilize product constancy to solve such examples. This is the concept where I'm using the formula of r%, and that's the more logical concept. It's purely your choice which way you want to go. You want to go this way or that way. I personally prefer this way. Let's move on to the next example. Virat sees Anushka at a distance of 200 meters and increases his speed by 50%. He now takes 20 seconds to reach her. Find, number 1, how long he had taken to reach her if he had not increased his speed. Number 2, find the original speed of Virat. Number 3, find the increased speed of Virat. Question number 2 and question number 3 need to be answered in kilometers per hour. The first thing that we need to understand in this question is that the distance traveled is constant. It is given to me that Anushka is at a distance of 200 meters from Virat. So Virat अपनी speed बढ़ाए कम करे जो मर्जी करे, distance 200 meters fixed है. So what we are considering is a case where the product of speed and time, which is distance, is given to me as 200 meters and it remains constant. Further, my question says that the speed of Virat has increased by 50%. Now, if speed has increased by 50%, time would reduce, and that reduction in time will be given as r upon 100 plus r. So if speed has increased by 50%, the reduction of time will be r upon 100 plus r into 100. Now 50 upon 150 is nothing but 1/3. So 1/3 into 100 means a reduction of 33.33%. So अगर हमारा टाइम 50%, अगर हमारा स्पीड 50% से इंक्रीज किया है तो हमारा टाइम 33.33% से रिड्यूस किया है. Furthermore, my question says that he now takes 20 seconds to reach her. What do I mean when I say he now takes 20 seconds to reach her? It simply means कि जो उसका ओरिजिनल टाइम था उसमें से अगर मैं 33% का रिडक्शन 33.33% का रिडक्शन माइनस कर देता हूं तो जो टाइम आता है वो मुझे 20 सेकंड्स गिवन है. He now takes 20 seconds to reach her. So original time minus the reduction in time, which is 33.33% of time, gets me the time that he now takes and which is given to me as 20 seconds. Now 33.33% can be better expressed as 1 by 3. So t minus 1 by 3 of t equals 20 seconds. T minus 1 by 3t gets me 2 by 3t. So 2 by 3t equals 20 seconds, which implies that the time taken originally to cover the journey was 30 seconds. That's the answer to the first part of the question. In the second part of the question, I am required to find the original speed of Virat. We are all aware that speed is defined as distance by time. Now the distance that we have here is given to us as 200 meters and the time under consideration is 30 seconds. So from here, can we say Virat's original speed was distance of 200 meters traveled in a time of 30 seconds. So speed ends up becoming 20 by 3 meters per second. However, my question required me to calculate the speed in kilometers per hour. Now, if I have something in meters per second and I need to convert that into kilometers per hour, I multiply the entire thing with 18 by 5. Now, 5 fours are and 3 6 are, that gets me 24 kilometers per hour. That was the answer to the second part of the question. For the third part of the question, I am required to find his new speed or his increased speed. There are two ways of interpreting the question here. One method of interpreting the question is to say that उसने 200 meters के distance को 20 seconds में travel किया है, which means उसका speed 10 meters per second आ गया, which obviously translates to 36 kilometers per hour. That's one method of solving the question. We will be basically reiterating the concept of second question while solving the third question if we are using that method. Another method, which is indeed a more common sense method, simply uses the percentage increase given to me in the question. If I have already deduced that my original speed is 24 kilometers per hour and there's a 50% increase in speed, that would mean an increase of 12 kilometers per hour. So I can say that my increased speed or my new speed is 36 kilometers per hour. Hopefully we are able to follow all the three parts of this question. One more example and then we end with the topic. A train left Amritsar at 6 am and reached Ludhiana at 9 am, where it met with an accident, so it stopped for 1 hour and covered the remaining distance till Agra at 75% of its original speed. If it reached Agra 4 hours late, what was the scheduled time to reach Agra? The easiest method of solving the question is to represent the entire question in the form of a line diagram. The train leaves Amritsar at 6 am. So 6 बजे सुबह ट्रेन अमृतसर से निकलती है and by 9 am the train had already reached Ludhiana. So the train had reached Ludhiana by 9 am. It is in Ludhiana that train meets with an accident and as a result the train has to wait 1 hour in Ludhiana itself. So अगर ट्रेन 9 बजे लुधियाना पहुंच गई थी तो 10 बजे तक ट्रेन लुधियाना में ही रहती है. So the train resumes its journey at 10 am. After this point, the train goes from Ludhiana to Agra at 75% of the original speed. So लुधियाना से आगरा जाते हुए ट्रेन की जो स्पीड है that is 75% of the original speed. Now the concept to understand here is that लुधियाना से आगरा का जो डिस्टेंस है वो फिक्स्ड है. ट्रेन अपनी स्पीड के 75% पे जाए, डबल पे जाए, हाफ पे जाए, डज नॉट रियली मैटर. लुधियाना से आगरा का डिस्टेंस फिक्स है. So again it's a case of distance being constant or the product of speed and time being constant. Now if the product of speed and time is constant and my question says that the train is traveling at 75% of its original speed, it is as good as saying that the train is traveling at 3 by 4 of its original speed. If the new speed of train is 3 by 4 its original speed, then can I say, in order to make this product of speed and time as constant, if train's speed has become 3 by 4 of original, the time taken should become 4 by 3 of original. सो अगर ट्रेन अपनी स्पीड के 3/4 पे ट्रेवल करती है तो स्पीड और टाइम का प्रोडक्ट जो कि डिस्टेंस होता है उसको कांस्टेंट रखने के लिए टाइम वुड हैव टू बिकम 4/3 which is reciprocal of 3/4. If the time taken becomes 4/3 of original, that's like saying that the time taken has increased by a factor of third. If I suppose the original time as t, can I say the increase in time is 1/3 of t? Question also says that the train got late by 4 hours. By the way, 1 घंटा तो ट्रेन लुधियाना में लेट हो गई थी. That means स्पीड की रिडक्शन के कॉरस्पॉन्डिंग जो ट्रेन का इंक्रीज इन टाइम था वो 3 आवर्स था. अगर ट्रेन टोटल 4 आवर्स लेट हो रही है, 1 घंटा तो उसको लुधियाना में वेट करना पड़ा. 3 घंटे वो जो लेट हुई थी, दैट कॉरस्पॉन्ड्स टू दिस इंक्रीज इन टाइम. सो 1/3t was the increase in time. This corresponds to 3 hours. So therefore original time t ends up becoming 9 hours. So the train should have taken 9 hours to travel between Ludhiana and Agra अगर उसका स्पीड कम ना हुआ होता. My question wants me to find the schedule time to reach Agra. अगर ट्रेन का एक्सीडेंट ना होता तो वो 10 बजे लुधियाना से निकलने की बजाय 9 बजे लुधियाना से निकलती और 9 घंटे लेती लुधियाना से आगरा जाने में. Now if the train had left Ludhiana at 9 a.m. and then it had taken 9 hours more to reach Agra, it should have reached Agra by 1800 hours. And if the train reached Agra by 1800 hours, that is as good as saying that the train reached Agra at 6 p.m. So what was the scheduled time to reach Agra? The scheduled time to reach Agra was 6 p.m. Hopefully we are able to understand this question. This is the maximum level of difficulty that you can have on the concept of product constancy. किसी भी हाल में प्रोडक्ट कॉन्स्टेंसी के सवालों का डिफिकल्टी इस क्वेश्चन से ऊपर नहीं जाएगा. विद दिस वी नॉट जस्ट कवर द कंसेप्ट ऑफ प्रोडक्ट कॉन्स्टेंसी बट वी ऑल्सो कवर द एंटायर कंसेप्ट ऑफ प्रोपोर्शनैलिटी बिटवीन स्पीड एंड टाइम. नेक्स्ट वी मूव ऑन टू द कंसेप्ट ऑफ एवरेज स्पीड.